not sharing.
Yeah.
Okay. Yeah, maybe I can
If
guess.
there's a little icon, it's, yeah, get rid of it.
Yeah.
Get rid of it.
Yeah, yeah. Let me. I think it's this one, right? Yeah. Okay.
Get rid of the okay. Just hit it.
Oh.
Then move the talking thing up there and get rid of it. So more, okay, move that up. And oh, now you're covering up some more.
I don't know.
Right? And then hide the meeting controls or whatever. No, top, yeah.
Here,
No, see more. See, there's a more on the top bar.
more on. Oh, here. Oh, okay. Oh, here. Okay, okay, cool. Yeah, I can get started. So this is a breakout session on Tuesday, and Professor Jiawei Han and I organized it. So yeah, so basically we have like a 21 people, like participants. So I actually already like list all of them here, and for some of them, I greatly appreciate their help. Like I already highlight their name in red. Like I chat with them, like they would like to contribute to our white paper later. And actually, for the other people, I haven't got a chance to meet them yet, like after our breakout session. But if any of you would like to contribute to the white paper for this breakout session, just feel free to reach out to me. And I have already, let's say, set up. Oh, so maybe this need to log in. I already set up some draft there. So if you would like to contribute to our breakout session, so you just need to prepare, let's say, add maybe 1 or 2 paragraphs on the examples on the foundation models that are used in your area or used in your research. Yeah. Okay. So for our breakout session, we mainly discuss like actually 3 topics, but for the first 2 we go a little bit deeper, and the third one we just briefly mentioned that we didn't get enough time to mention that, like this. Yeah, so for the first part, I think it's about mitigating LM hallucinations for answering scientific deep questions. And I think Professor Jiawei Han gave a very nice introduction about like the ideas like behind. Of course, like we know, recently this LLM we leverage it to answer some simple questions. They are doing okay, but if we want let it to help us to answer like a deep scientific question, it will be super challenging. It will give us maybe incorrect answers, and it will generate many hallucinations. And how can we solve that? How can we address the problem? And the idea, I think, so Professor Han mentioned a very interesting idea is, okay, we need to do RAG, but not like it's called like a retrieval augmented generation, but it's not like the simple RAG, but we want to do structured RAG. Yeah, so here RAG is just means, okay, we first would like to have a retriever and maybe go through our corpus or some big database to collect some relevant information, like a relevant text material, and we provide that to LLM. But here the keywords is structured. So structured is based on our understanding of the scientific problem. We want, let's say, do some pre-processing of the retrieved relevant text materials. We want to make it into maybe structured like a knowledge graph, like some graph structure to, let's say, to identify or to indicate the relations between this relevant information before we send that to LLM. Okay, and after we have this structured RAG, then we can, like a structured knowledge graph, like based on our retrieved material, then we can send them in some natural language way to the LLM. And we expect that in this way, this LLM will give us, let's say, will work better to digest this kind of very deep knowledge and give the right answer, figure out the right answer to our scientific questions. So this is the first part. And we also, for the second part, we also talked about some potential computation challenges for LM or foundation models in science. We know yeah, so those kind of models, they are super large, like they are hard to get trained, although recently we can leverage some pre-trained model and maybe fine-tune them into our let's say vertical domain. So but even we can leverage those pre-trained model when we want to deploy that, we still need a lot, let's say a super like a very large like a great amount of computation resources to support that, right? And in particular, in some of applications, we even have a really large data amount, like we want to process that in real time. For example, the let's say the applications care about like in A3D3 Institute, like yeah. And for we know there could be a computation challenge if we want to leverage this foundation model in science. And in our breakout session, I give one example that potentially we can handle that. That is, we may leverage our, again, like our knowledge or our understanding about like inductive bias in the physics or in our problem to specify the computation of the let's say language model or like the foundation models. So I introduced one example that we leverage the let's say the inductive bias, the locality let's say locality inductive bias in the let's say point cloud data generated in the Large Hadron Colliders. So and specify over the transformer model to get an efficient processing of the data there. Yeah, so this we have discussed, and we also briefly talked about like what could be some future, like an innovative way to simplify the computation for the LLM for the scientific research. And we discussed about like whether we want to use mixture of expert or maybe standard like full attention or maybe some other let's say inductive biases that we can elaborate here. Yeah. Okay, and for the third part, like we just briefly mentioned that we didn't got a chance to go into the detail. It's about like the data diversity or quality when we want to train or fine tune the foundation models or LLMs towards our the problem of interest to us. Okay, and we know these LLMs and the foundation models, their effectiveness is actually built based on this large and diversified data, right? And otherwise, as I mentioned in the first part, like they may just generate hallucinations. And yeah, so it could be like a very interesting problem in the future to think about like how can we like improve the data quality or diversity in the scientific domain so that it can help to fine tune or like trim the LM or foundation model towards the problem we are interested in. Yeah, so that's all for our breakout session. Yeah, any? Yeah. I guess we don't have Catherine also. Yeah, go ahead.
No, I was just saying, do you have some actions that you would, I mean, what should happen after today in this area for the HDR? Should, yeah, do you have any thoughts on sort of, because I think every one of the sections will have, you know, here, you know, a paragraph that'll describe, you know, the next steps are to explore this further, or to understand, like, you know, each of the HDR element, each of the HDR projects, what their challenges and opportunities are in large language models for their science and maybe transform whatever. Like, are there, you don't have to do it right now, but do you see some things that you could suggest in the report of what are the next steps?
Yeah, so let me just give a few examples. I think like for each of the part I'm just mentioned, there could be some very many actionable stuff that we can do. Like for example, the part one, like for example, we are not mentioning structure rag. I can imagine. I know a bunch of work right now are doing RAG, but there are not like but the important thing, as I mentioned here, is structured. So basically, how can we, if we have some relevant information, for example, for material science, we want to design molecule there, and we gather the material like a literature, and how can we extract the knowledge from that to organize into knowledge graph so that can help LM to answer the deep question there. So of course, like this is one, let's say, example about the actionable thing we can do. And for the second one, yeah, it's just like I have mentioned, like the inductive biases. Yeah, so I gave an example in high-energy physics. You also know about that. Like, but for other application domain, like weather forecasting or maybe some, yeah. So or I also heard, yeah. So maybe some material science. We also know like. Some people here also care about like whether some kind of like a prior knowledge we can leverage to accelerate the computation of the foundation models. And I even know like right recently, I know a lot of people from DOE ask me about like how to accelerate let's say GN or graph neural network foundation models for material design there. Yeah, so yeah, so
maybe try to develop that a little bit, because that would go into the report. I think this is a kind of, we don't have microphones today, but
yeah.
If you actually have a question or something, yeah, you can stand up here. Yeah, I think this is a topic where it's big enough and hot enough, and I think that's true for all of them, by the way. But like maybe you should think, maybe one bullet would be to have a dedicated like half day, I don't know what you would call it, mini workshop or something, where we just have the, people interested in, transformers and LLMs and large language models, the same thing, just to get together for like on Zoom and like some structured discussion about it. So maybe that could be an action, is to have a future, like in the next small number of months, get together and understand people's problems and opportunities in this area. Yeah. So we could, maybe that's true for all the areas. We should have like a topical workshop, but okay, think about the actions so that we can write that, because that's going to be a section in every section of the report. Yeah. We're going to want to have something like that, which is next steps section. Okay.
Yeah, I can add a actionable section.
And do you want to have I noticed you have a separate overleaf, totally fine. If you want to do it there and work, and that's nice, work off to the side. We do want to have just a single white paper then, but that's easy to just copy the text into the.
Yeah, so
but I think it makes sense to work off on the side. And one of the things that everybody probably should do is we'll either do it in the main document, or I really like what Pan did. Maybe that's is to have a you're gonna have an overleaf, and then you're gonna have to make sure you link share with the editable overleaf that you can start to work on the text.
Yeah.
Okay. Thank you, Pan. Let's see. Oh, any other questions? I kind of just asked it and then said to get off. Okay. All right, thank you. Let's see. Let's go to so actually, I noticed you're here, Savannah. Is it okay if you go? I'm just going. Oh no. Let's see. We're doing it in random order. Okay, who wants to go next? Anybody want to just kind of go next here? Okay. Step up. Sorry? Human in the loop, yeah. Okay. Let me just check that it's being shared.
How can I pull the mic down?
Yeah. That should be good, right?
Hello, everyone. We had a good chat in the breakout for Human in the Loop. So the topic basically was continual ML and human in the loop decision making. We combined both of them together, and we talked about human in the loop AI. And a little bit of the discussion was how we interpret this term, and how we, like the majority of us saw it was human intervention when we are training neural networks, machine learning, and AI models. So we had roughly 11 questions, but I don't think any group actually got the time to go over all 11. So we took 3, the first one, the middle one, and the last one. And the first one was about the challenges or the limitations that are associated with this process of having human in the loop. So the first one that we all had a consensus on is the bias that travels from human rationale to the model that is being trained. So that bias basically amplifies as the model keeps on fine-tuning. And the second thing is contextualizing data. So this is coming as a challenge because it has two parts. The first part is how do we figure out what data is useful to ask? And second is now how do we figure out what to ask a human to do it in that regard? And then how trained should that human be for that task? So that brought us to some priority research directions for data-driven discovery. Now, this is something to mitigate the problem or the limitation and challenges that we identified. And one of them, one of the key ideas discussed was to have explainable AI approaches. Because let's say if we have a biologist in the room and we give him a machine learning model and we say that this is data-driven discovery, it can take away human from the loop, he would never trust that black box. So we have to come up with more interpretable AI approaches to build that trust on the AI or the neural network models. And the second one, we all know we had this wonderful keynote talk that is to have knowledge guided machine learning. So we don't actually have a human in the loop, but we might have the human knowledge in the loop. Fed differently from how the human biases and rational would be feeding in. And the third one is the education and community outreach that could be done for the second part that we have discussed for the data-driven discovery part. And the first one would definitely be to have more primers. So these are basically manuals, tutorials, guides that help move or transition from HITL to D3. So I've just put these abbreviations. I'm not sure if they're coined, but I figured it is easy to write. And then we can have some best practices that are well documented, some do's and don'ts about the process. And then we have to energize the next generation. So we have to energize the new upcoming generation through outreach events that could be depending upon the age group that we are targeting, ranging from camps, workshops, summer schools, and undergraduate research symposiums and things like that. So that is pretty much all we were able to cover in an hour, including the introductions that we had from our 13 participants. Thank you.
Thank you. I think you mind staying up. Does anyone have any questions or comments on this area?
You can share feedback. Don't ask questions, please.
Feedback. Yeah, go ahead. Yeah, I'll speak up because we don't have the mic, so you speak up. Knowledge guided machine learning.
Yes. So you're saying there is no way we can get rid of the bias? Mm-hmm. Mm-hmm. Okay. So we can control the influence of bias, but we cannot control the bias coming in, right? Be it little or more, it would be there. Yes.
Just to follow,
Mhm.
make a comment.
Mm.
It may be totally impossible to get rid of bias 100%.
Yeah.
It can be significantly minimized
Hmm.
by including diverse knowledge, like
Hmm.
not just generated by one expert in the field
Mhm.
or just a small group of people.
Mhm.
Looking at the knowledge base that guides the machine learning
Mhm.
must be from a diverse set of participants and diverse set of data.
Mhm.
Different people, different ethnicities, different parts of the world, that could minimize the bias that we want to get rid of.
Mhm. Yes.
Going with that, I think one thing that could be a bullet point somewhere there is diversifying the research pool. Because too many people like us thinking about these things,
Mhm.
not too many people like the people who want to study.
Oh, yes, that's an excellent one. Thank you.
Speaking of again, another one. Like when you are thinking about that is available there, right?
Yes.
So if you just
or are the same thing with the company?
Everything that can come under this term and that can come under this umbrella that can help interpret the models better and leave us with, like, help us overcome this notion of black box. So we don't want the models to be black box anymore, even if they can come out to be gray boxes, a little more transparent, that can go in under explainable AI. So all those techniques are welcome.
Also, you want a model to tell you when it doesn't know the answer. Like that's why I've been working on this thing called evidential deep learning, and it's the whole thing is when the model will give you a point estimate, 50-50, 40-60 of two classes, but you want it to tell you, I don't know, I've never seen that before. That's an out of distribution. And that way we can, that's an uncertainty quantification, but it's also a way of understanding the model telling you of its degree of belief. And that's an example of explainability. It's really important. It's not part of most machine learning. So like, yeah.
Thank you.
No,
I was just gonna say this trust building piece. Also, like the communities that are affected by AI and the kind of approaches for doing that. So just comment, I guess that could be really like powerful during section of the way deeper.
Excellent point. Yeah, when we remind me when we get to the white paper that there should be cross-cutting discussion that it's not every section, but things that cross across them. Keep going. I'm going to go see. I'm seeing the actually benefit from microphones now. I'm going to go see if I can connect people. Yeah, thank you. Thank you again. Shouldn't be too hard to do this stuff. I will be back.
So thanks, Hara, for presenting. It's a nice gateway to our breakout session. Since we are talking about the knowledge-guided machine learning, and also we are also talking about the bias. Let me find. Okay, my name is Jianwu Wang from University of Maryland, Baldwin County. We have Zhijian from UC San Diego. We moderated this breakout session on network-guided machine learning. So we have also very large participants. I think one thing, this is a topic connects all the institutes because every institute have their own discipline to work on. That's one reason we had the keynote. Let me try to do this. What's floating? Okay, so that's why we had a keynote on this topic. So everyone went to this breakout session already have some understanding of this topic. Well, several things discussed. First, it's the still basics. What is knowledge can be leveraged by these types of research? How do we encode them? How do we what type of format of knowledge can be? In theory, right now, most people, I think the keynote talk about the PDE functions, maybe others, symbolic equations, just correlations between maybe two processes, two variables. They have some positive and negative correlation. Knowledge graph is also very popular. They are one way to represent knowledge and ontology. There are also multimodal knowledge where they have not only texts, have numbers and also images and videos. How they can all put in this knowledge-guided machine learning. That's something we discuss a lot. Second is the life cycle and the pipeline. I think if you read the knowledge-guided machine learning, there mostly is one big paradigm talking about their model, either they use knowledge on loss function or use it on the architecture. I think these things go, we think this go beyond that. I think there's ways you to how to, for example, it should be an iterative way to do it because we will never have a complete knowledge at the beginning, and the knowledge also evolve over time. How we can do this like this? We maybe start with some basic knowledge and when we apply it with the data, we find some mismatch. Maybe that's where we find new knowledge need to be added, and what's the context of those knowledge, and or how to decide which knowledge should be included in the model. So that's the goes beyond just one time of training. and a way to evolve. The third one is because the whole HDR it's about data. So we talk about the data collection annotation. Is there a way to tell whether current data is sufficient? You know, if we have we all know garbage in, garbage out, but how do we know we have enough data set for this types of research? Is there a way to identify the gap between the existing data set and what the additional data set are needed, and how to prioritize those, including different models of it, like images, videos. Those things can generally help. Is there a way across different disciplines, domains that have general process can not only help the machine learning, but also help going back to the data collection and annotation part. 2 parts for GG.
Yeah, we have also touched upon the knowledge discovery using KGML because KGML is mostly about how we can embed the knowledge into ML, right? But how can we actually discover new knowledge from the ML so that we can create a cycle between ML and knowledge. So not only ML can help us, the knowledge can help improve the machine learning model, but also the other way around, how machine learning model can help us discover new knowledge. So can new physics be found from this process? We have also talked about the knowledge bias. I think the audience has also raised that question earlier. So because when we bake the knowledge into the machine learning model, we might intentionally add bias to the model, right? And how can we be mindful about this, and how can we prevent this? And when the knowledge we bake into the model is not perfect and also is evolving, how can we improve the model consistently, and how can we keep that in mind? I think these are also some topics we have covered. Yep.
That's it. I mean, anyone who participated want to add anything?
We haven't, but anyway, yeah, another question?
No.
I would have the same comment I've had all the other ones, which is that, yeah, make sure that when you write the report and you start thinking with you two and whoever else is here in your group, that what are the actionable items after? What do you want? What should you do after?
I think one least thing we could do is to go back to each institute and everyone in this meeting, because not everyone in the institute attended this workshop or conference. I think every institute have done something related to it. At least we can go to have a paragraph on what you did on this particular thing. You know, maybe papers on it, put the application, how you did with knowledge. I think that's a good some kind of survey within the HDR ecosystem, how it is useful for niche.
Yeah, so almost always the first thing is information gathering.
Yeah.
But then, you know, you might want to think about whether there should be maybe there should be a plan over the next year. So I kind of think we have between now and the one that's going to be held in OSU. We can act on all these things. We should have probably all these breakout topics that go in the report should also have an associated meeting to discuss and develop, and maybe there's like a shared repository of code, or maybe there's, so just sort of think about, but I think you're right, the discovery part of it is the first thing.
Yeah.
That's clearly actionable, but maybe also, anyway, just think about it for the report. Okay.
Next.
If you go next, yeah, go. Yeah, you'll do that. Oh. We have discussion.
I'm gonna lower the bar. We don't have a formal slide. We didn't follow any questions. It's terrible, but I do have something. I have a slide, but the reason why I wanted to go next is that the word bias came up, and the idea of incorporating knowledge into the algorithms is perfect. I think it's a perfect idea, except for when potentially you're adding some sort of bias. Can we associate some uncertainty to the knowledge we impose, right? Can we allow for some variance to the predictions we make based on how confident we are in the knowledge we impose? Those would be some big picture questions. All right, so related to what we discussed, how do I get there? All right, I'll try it. I love it. Oh, okay, second tab. Yeah, there we go. Right, so we didn't answer any questions. We just got out our iPad.
It's thinking. There we go. All right. So we had a list. We had 1, 2, 3, 4, 5, 6, 7, 8 folks who attended our discussion. And really, a lot of our discussion was also just how do we define uncertainty, right? So with that, the conversations came up of what are different types of uncertainty. And at one point, one person used the word systematic. Systematic uncertainty for us statisticians tends to be what we call bias, right? But then you have some random error associated to potentially our predictions. One source of that random variation is the data collection itself, whereby you have different samples of data, which would result in different predictions from the data. And so you have natural random variability in these predictions solely on the very fact that you're collecting data from a population. To try to express that, we then started drawing. We had our fabulous Venn diagrams with a population, and you have your sample data set with some prediction coming out of it. And one source of uncertainty is the variability in that prediction, and we have to estimate it. Yeah, so then when we talked about, we really did kind of jump around what are kind of some current strategies to try to quantify uncertainty. And current strategies would be the testing and training data sets, splitting up our data as they are. And there are certainly some pros to that. Of course, it's easy, well, air quotes, easy, right? We know how to do it, but it's limited because again, this uncertainty is not about the relationship between the data we have and the larger population. The uncertainty is about truly just within your data, the variance of predictions that can happen only within your data set. Then we started to try to provide an example of what we're meaning. And I think if I were to redo this, I might have a more streamlined way of us engaging the conversation of uncertainty. But we had a bunch of folks who were very familiar with BioClip in our group. And so what we then discovered is that with foundation models, you have a different way of trying to think about uncertainty, just another form for us, or another level for us to think about where and how and if we can impose some sort of measurements of variance or measurements of bias from it. So with that, a little bit of education was required. In terms of the foundation model, once it's been created, we think of it as fixed. And really, it comes down to the downstream tasks and what results take place on the downstream tasks. Okay, all right, so now we have the population of downstream tasks, right? And we're sampling or subsampling from the possible tasks. Okay, can we even do that? Can we even specify it? I mean, these are, again, big picture questions, almost philosophical questions, but do allow us to think hard about measurements of variance among varying predictions. Cool, yeah, let's see. So then, yeah, we ended with, well, we don't know what we don't know. So that's how we ended. We also ended with some ideas that I've been kicking around is trying to figure out if we can develop a true residual analysis methodology to some of our AI predictions and see what we can go there. And then I didn't know how to erase a whole bunch. And then we just started talking, had a little bit of statistics lesson. So I crossed it off. All right, so that's the story for us. My tagline, that's a story, more than glory. Any questions, joys, concerns? Yeah. Yes, I don't know if I quite heard you. I think you were talking about once we start deploying the model. And I thought I heard patience. Is that what I heard you say? Oh, it's an important topic. I agree. It's essential for sure. NSF funder, keep us in mind. All right. Any other good questions? Cool.
Where do you go next?
Well, where do we go next? Well, so I would say, I think if I were to redo this breakout room, I would really just start with maybe some fundamentals and try to list out where are all the places we are unsure, and just try to really identify sources of error that could be imposed. whether it's in the data we collect, that would be certainly one source of variance. When we think about our model, where are the places in our models that we are having choices and making decisions? For example, the knowledge that we impose, that would be a source of uncertainty, right? And then keep going down the line, right? And then see what we can do to try to develop methods from there. Yeah.
Is that what you want to explore going forward?
Oh, yeah, I think that could be good.
Yeah, because like when we write in the report, we say, these are the activities that are really going to develop this area.
Yeah.
Here's what we should do over the next year. You don't have to answer now, but just again, like.
Okay, I hear you. Well, I think that I do think that that's a good place for us to start, because everybody's going to have different opinions, and that's going to be a hard task because the models are so different, right? We have different sort of categories and versions of the different AI methods that we're using. Developing a foundation model is going to be very different from applying some run-of-the-mill model on a different application. So we start thinking hard about different types of models, and again, thinking hard about where are we making choices, right? And what are the consequences of those choices.
Thank you. Thank you, everybody. Okay.
Because it's the importance of this topic, maybe next ML challenge can be based on uncertainty of quantification or reduction, right? How do you reduce it, compete? I think then we boost the community to work on it.
All right, so he's saying we're committed.
We have a comment. We'll comment about that at the ML challenge when we go up. Maybe we can go up next, but we have a related comment that basically say the answer is yes, but it's slightly more complicated.
And then
Like we have a plan to get to uncertainty quantification, but it's a 2-year plan.
Yeah, and I have just a comment for, being a domain scientist who doesn't do this stuff. Like, it'd be really cool for the different methods if we, if you just had a summary of what are the sources of known uncertainty, unknown uncertainty for the different methods. Like, I could see just a table and a review paper for, environmental scientists and ecologists, or, other folks that are interested in applying this stuff. Like, it could help us narrow in on what techniques to focus on.
that's a great idea. Cool. All right, passing off to the 2-year plan.
Plans are good in 2 years. We can't go too far after 2 years because we don't, a 10-year plan would not probably be a little beyond our. Okay, let's see. Who do we have next? Ethical foundation, human loop, certainty, knowledge. Oh, did we do knowledge guided? I can't remember where we're at now. We just did that. Yes. Workforce development, we have not done. And ML challenges. Okay. Yeah. Let me, oh, I didn't do what I said I was going to do, which is to put that. Oh, your, ML challenge. Oh, okay. He said, let's do it. And then he didn't come up. Okay. Thank you.
Said, let's do it. Elizabeth, go get
Great.
up there.
Great. All right. I didn't yet put it here, so I have to go back to, shouldn't be. No, I know, but the Google Doc. Yeah, no, I know. I just need to go to this session. Wednesday. Thank you. And then it's this one.
Okay. You said it's at the bottom? Second page. Okay, cool. Plan of action. All right, so we're very excited about the launch of the ML challenge, and we're now basically doing, as Phil was alluding, we're going to do a 2-year plan so that we can get to uncertainty quantification, because that's a big problem and really interesting. So the idea would be that first we're going to do, we're going to keep the focus kind of on the out of distribution anomaly kind of realm, because it's kind of the easiest way that we can all overlap. So we'll do an out of distribution problems next year. And the idea would be to get some multimodal and have some metadata and our base data. And we want to bring everybody in going forward. So we're looking with the idea of doing a NeurIPS workshop next time. And then for the uncertainty quantification, the idea is that we're going to request a NAR pilot so that we can train some foundation models with that.
And then that way we can provide the foundation models to the people in the to the people doing the challenge and some extra data, and they can try and figure out how to do the uncertainty quantification, and they have something that they can fine tune or work with in general. And that way we're combining the anomaly detection from this year with the out of domain challenge for next year into like a final kind of wrap up all of the things together. So we're going to work on pulling people together over the next few months to start organizing, to start planning for the next year. And we really want to make sure that everybody gets involved this time. And we'll start planning, and we can do like we did with this time around. We had each institute, we kind of looked at the data we had and what kinds of problems we had and did presentations for each other so that we could talk about what our ideas were and what we wanted to do. And so moving forward, that would be the goal. Yeah. She needs a mic.
So I run the machine learning and physical sciences workshop at NeurIPS. So if you're interested in collaborating on that, I don't know what you had in mind for like a full workshop on this topic, but we get requests every year to like host a challenge as part of the workshop. And so far none of them have been good. Like we've said no to all, or the challenges themselves are probably fine, but they haven't been the right fit for the workshop. So we've said no to all of them, but it's something we're definitely interested in. And you know, we have to see if we get accepted again next year, but so far we've been accepted every year. And I think it could be a really good fit to like collaborate on that and really like integrate it from the beginning. Cause yeah, I think it's a great idea to bring this to that kind of community. So if you want to talk more, happy to do that.
Yes, let's talk, please. Awesome. Justine.
From experience with the annual challenge, I know you guys are doing more technical work, but have you considered involving like the K-12? So have you considered involving like the K-12 or the community colleges in like pre-challenge activities that would then sort of pave way or set the pace for the broader or larger challenges for the more the technical experts in this case? I don't know, have you thought about it or considered it?
Do you have ideas of what that would look
Like
like?
maybe how would the K-12 help you label anomalies, you know, give them some fun activities and then see how that can translate into a broader challenge, you know, yeah, because if you have a whole year of
Get
planning.
kids to start like labeling animals when
And
we're doing
exactly,
when we're
right? The
doing
hybrids.
at the ID4 workshop this summer, and we were talking about planning things for students to do. Some of the teachers had like camera traps that they were going to set up, and they're like, yeah, our kids would be totally into like just labeling them themselves because they can label the animals. So
And maybe this is a suggestion for the organizers of this conference in general. It would be nice to have a central place where you can sign up to participate in all of these branching activities, because, you know,
so if you want to
especially I
join
can
the
speak for
ML
myself, I am
challenge-
quite interested in a few different things to sign up and work, and it kind of gets convoluted in my head. Okay, whom to talk to do this, to do that.
Oh,
If we have a
hold on.
central place where we can
There we go. Okay.
sign up to participate in each one of these, that would be nice.
So if you want to do the ML challenge, go to the workshop page, come down here on Wednesday, go to the machine learning challenges, future ML. That will open up the Google Doc, and add your email and your name. Phil, maybe we can make a table here or something.
Now, is that a way we can do for all the different sessions?
Yeah, I know, but
Yeah. Wonderful. Thank you.
I just want to comment on the Emerald Challenge with the K-12 students. Actually, for the current Emerald Challenge, we had a high school student to test out the Coda Bench system. So if it is something we should consider to highlight as one of outreach, and we could also fold this into this report. But I don't know what would be the systematic way to grow it up to the nationwide K-12 machine learning challenge. This would need education team to think more how to do that.
I mean, they would all be welcome to join it anyway, since it is a publicly open challenge. So anybody who wants to can join. I know we also had, this summer, we had an intern through the Skype program. There was a talk about that. I think it was yesterday. And so that was like a community college partnership that we're working to train up more research software engineers and such. And so that could also be like a link of pulling in more people who could be dedicated to working on parts of the challenge as well.
I like this idea of bringing it into the K through 12 for the challenges. That could be really, I mean, think about how like the like Science Olympiad and all these things of really like, interest in science has been developed and established by having high school students or K through 12, like really the K might be a little, I can't think of how we could do the ML challenges for the K, but as you get closer to 12, certainly the high school level, where I think that could be really like bring in people that really a lot of interest in schools. So we should think about how we could do that. Yeah, go ahead. The microphone.
Use the kids to develop a baseline human version.
Yeah, I mean, high school level could definitely do ML challenges. We just have to make sure it's crafted in the right way.
I was gonna add, I'm doing a railroad transforming the workforce, and I think we actually succeeded in having high schoolers even flying around the country for 1 week. So sometimes we're thinking it's impossible to do, but the high schoolers are ready to work remotely, but also if we had them to go to one place for 1 week, they can, it's a little it's not common, but it has they respond, the families are ready to send them. So that just wanted to share that.
The high school one is you have to be very careful about how you manage the high school ones, because the high schools that do really well on a lot of these challenges are all high resource, high-end high schools in places which are not minority, not under-resourced. And so we need to be very careful how that gets addressed.
Well, thankfully, we have a national program called NAIR that's supposed to democratize access to AI resources. No, I'm actually serious.
Yeah,
so
but you also need to have the high school teachers who know how to use NAIR.
Yeah, no, I know that's, but I'm saying in terms of the resources, hopefully that NAIR, I would agree with you, they could never train machine learning models. I mean, that would be of use at a high school level because nobody has any money to do anything. But I'm saying NAIR now actually addresses that, and it also should have a training component. And so, yeah, I think that NAIR might actually be an enabling element for doing this into the high schools that could never be existing before.
I was gonna say, I can host it because this summer, 6 of them came from Chicago, and the 6 of them were either Hispanic or female because they like New Mexico to be. So intentionally, we can work on that problem from the design.
Yeah, we do middle school. We have the middle school data science camp that's basically focused on, like the city kids in Columbus. Similar overlap. Maybe we could learn something from the Quest folks because they do teacher training. All kinds of overlap. Or talk to some of the other data science. There's an education group that I connected also that is looking at like mostly 6th through 12th, I think. And we could bring them in on this.
Yeah, and this crosscuts with the education repository because there could be training materials on how to use NAIR resources for ML. So yeah, this is a cross-cutting thing. But actually, bringing this into the below the into the high schools would be really cool. Okay. Yeah, other comments? Okay, I think so. I think the ethical AI, I think, is the next and possibly last. Oh no, Josephine, wait a minute. Sorry, there's 2. Ethical and the workforce development. I apologize. We'll save the best for last. How's that? My current former chef person. Yeah, you know all about Indigo.
Yeah.
If some of you are perplexed, this Indigo platform, we really love it. It's like one of the, I think, highlights out of it in terms of the collaborative tool.
Yeah.
So the person who suggested I make this diagram is not in the room today, so I'm a little sad about that. But yeah, I'll get into our discussion on ethical AI. So I think we had some really great framing slides that Peter and I put together that I would encourage you all to take a look at if you're interested. A lot of like resources and readings from lots of different perspectives, very technical perspectives through like participatory design, philosophical perspectives. So lots of good stuff in there. But yeah, to try to summarize our very broad, very interesting, sometimes slightly heated conversation, I think two of the big things that came up were what is ethics, right? We're doing this ethical AI session and this explicitly came up. What does ethical mean? And also the question of like, you know, given how you might define ethics, is it possible to do AI ethically? And we had varied opinions on that in the room. But I think what we really hit on is that in order to define what's good, what is ethical, it's extremely context dependent. And we talked about different types of context that matter to deciding whether your approach to AI, your AI system, whatever, is ethical. And some of those things that we talked about were the communities that are affected. So are we engaging, especially if we're doing any kind of research with a social application, whether it's geospatial mapping or you know, looking at more kind of social science research, but also even in a more pure physics context, you know, how we communicate these results to people. So really thinking about the communities that are affected by our work, how do we communicate with them in a way that they understand? How do we think about consent for data collection? How do we think about what people even want from technology? You know, we're all pretty technical people in this room. We have a certain idea of what AI should look like, but how are we engaging the communities that are impacted by it? We also talked about like, you know, you can use the frameworks of your collaborations or your organizations to decide what is ethical. So the iGuide kind of slides that Peter had were a really great kind of example of this, that, you know, he talked about, we have these specific values for what we want our work to be. And so then we can evaluate if we're building an AI system, does it match those values? Are we incorporating those into our work? We also talked about it's really important to think about forces and incentives that are at play. So we, of course, as scientists, have a incentive for knowledge creation and proof and truth in these things, but in the broader AI space, there are a lot of political and financial incentives at play right now that affect our work, but also the broader ecosystem of like, oh, you are here. Yes. Sorry. So yeah, lots of incentives that are at play that we really need to be cognizant of. And then the last point that I think kind of falls in this context discussion is thinking about the spaces in which AI is developed. I've seen points related to this come up in a lot of the other summary discussions that were shown. So this is things like thinking about our data sets. We're building benchmark data sets. Do they really mimic the real world problem that we're trying to solve? We develop AI systems in pretty like clinical, you could say, contexts where we've curated a specific data set in a nicer, clean environment. In the real world, we see a lot of things like domain shift, transfer from lab environment to the application environment, more uncertainty, more messy, more incomplete data. So thinking about how the context in which we actually do our research affects how the models are used. And then getting into some kind of important points, I think, that we talked about that might make the basis of some ideas for the white paper. So one thing that came up a lot is the real critical need for researchers to really understand their data sets. And, I'm sure you all know this is important, but especially in interdisciplinary or multidisciplinary work, it's really important that we don't just take data and then hand it over to someone to build a model who doesn't understand things about where that data came from, how it's collected, how it was sampled, even from an uncertainty standpoint. It's really important to understand the sampling processes of our data. And then as well, when we're thinking about anything related to humans and societal data, what consent was involved, what did we tell people about the data we're collecting, what we're going to use it for, all of these things. And again, hitting on that community point, we really talked a lot about how both collaboration with domain experts is important, but also working with our communities to understand, everything from concepts of possible data sovereignty, privacy concerns, but also how we share the benefits of our work with them. Related to that, we talked about the role of open data and open science in doing more ethical AI, things like balancing privacy with utility to the community, making sure we're democratizing all of the benefits of our research. And then I mentioned this point during the human in the loop discussion as well. We talked a lot about trust building and what does it mean to build trust in AI. And there's a really interesting point that came up about we put a lot of trust in a lot of systems. We trust doctors to take care of our medical care, well, at least somewhat, without being medical experts ourselves. We put a lot of trust in someone gave the example of our bus driver on public transportation. We trust that he's not showing up drunk to work every day and going to crash the bus because there's systems in place that would, either prevent that from happening or not let it hopefully happen on a repeated basis. And so we talked about when we're talking about trust in AI, where are we talking about putting that trust? Is it in us as the developers or the researchers? Is it in specific technologies? Maybe we trust decision trees that are directly interpretable more than something like a transformer that's very hard to explain. Do we put trust in institutions like companies who are developing cutting edge AI, or do we put trust more in the first principles? If we can kind of map out the theory side of our systems and we can say this is what the model is actually doing on a mathematical level, as scientists we tend to put a lot of trust in those principles. So yeah, thinking about both for ourselves as researchers and then the broader community, funders, people who are using the technology, what angle of trust building do we take? We also talked a lot about technical literacy. So this intersects with a lot of points that I already said, but thinking about how we can help communities understand technology enough to consent to the kind of AI systems that are being used to make decisions about them and the society and technical systems they live within, how to make sure, again, that communities are reaping the benefits of this research and that they can advocate for themselves against potential unjust or unethical uses of AI. And this really intersects with the trust building point. And then the last thing we talked about is culture shifts. So this point has come up a lot in my work. I linked to a recent paper that we wrote about ethical and responsible AI, specifically in climate science and AI. And we talked a lot about this culture shift point of there are potentially ways that our publishing incentives, our hiring structures, our tenure evaluation structures enable more unethical AI practices, either rushed publications. We're not thinking about things like explainability or uncertainty in our rush to just get a new idea out. So I think that could be a really interesting point to talk about in a white paper. It's a little spicy, but I'm
about spicy takes. So, and then the last thing I'll mention is we also talked about, which I think is a really important point for discussion for the white paper, is where should our focus be right now in these efforts? Should we be talking specifically just about like scientific AI that maybe is coming out of the HDR institutes? Should we be talking about what we as scientists can do, like where our unique skills lie? Or, you know, do we want to kind of take on the whole beast of like the AI system as a whole? So yeah, that's what I have. It was a really fun session, super excited to be here and doing this with Peter, who was also really great. And yeah, we'd love any feedback or questions or anything.
Thank you. And we're so happy to have you too. And even though you're not like in the HDR formal, but I hope that you'll continue to be an author on this white paper, help lead this. Is obvious an area that you're passionate about and an expert in, and that's why we have you here. And so I just want to thank you so much for coming, and I do hope that we can continue to take advantage of your talents as we get this white paper out.
Yeah, I would love to be part of it. Thank you.
Are there questions or comments for Savannah? Feedback of any sort or thoughts about maybe also where to go with this, aside from the white paper? Hold on one second.
Yes, they're on the Indico for our day. Yeah, on Tuesday.
Yeah, we're very proud of the fact that in HEP, we always post all the slides. I don't know how frustrated I am as I go to a AI conference and the agenda's there, like, well, I want to look at the slide. Well, they're not posted. Sorry, we're not public. Or maybe we'll post them after. Like we always get them up in real time because
Yeah.
That's a pound back for HEP. Oh, I don't. Okay, I think we're done with this session. Thank you. No, I can't. Goodness. Sorry. Feel free to come up. I'm so sorry, Justin. Gee, I forgot not only once, and then I recovered by saying save the best for last, but then I forgot again. That is completely inexcusable. Oh, sorry. Let me just see. Yeah, it's in here. I have to go to the session. Okay, yeah, you were the power. No, you're having Google Slides, even though it said right here. Oh no, really? No. Oh. That's bizarre. Don't know why that is happening. Sign in. Okay. Let me think about what to do. Fine on my laptop. It's not, it's just a Google slide. Oh, maybe the link. No, it shouldn't be that. All right, let me just try to repost the link.
Yeah.
Is it refresh?
Oh, and maybe I only gave you my access, so it's not anyone.
Yeah, but I didn't have to, you didn't give me specific access.
I did.
You did. You actually put MSN. Oh, okay, yeah. Could you change it to allow link sharing for view? So do you have your not no okay. Oh, but since I have comments, since I have access, I think I might be able to do that. Let me see. I don't know if it's only good.
I'm getting to try your access.
Oh, okay, then I think I can do it. Share. Yes, I can restrict it. Okay, that's fine. Anyone with the link can. Okay, try to reload it now.
Okay.
Actually.
Yeah. Perfect. Okay.
Okay, go ahead.
Okay. So good morning. My name is Josephine Amayanja. I'm from UMBC. I'm also a part of the IHAP family. So our breakout session was focusing on workforce development and in the interdisciplinary career space. We had several participants from various institutes, different levels. We were happy to have folks who were really involved in the workforce development area. And so we're happy to hear from their expertise as well and what they had to share. But what was most interesting is that as you look around the room here, we're an interdisciplinary team in various aspects, right? So the ID4, iGuide, A3D3, Imageomics, all of you are interdisciplinary. So we wanted to first start out defining these concepts. First of all, what does workforce development mean? And given we have students, we have researchers at different levels, faculty members, practitioners, and so on, what does this mean to different individuals? And generally speaking, you find that folks are interested in finding out that they can apply what they have learned or experienced in education, those skills, and take them out into real-world applications. Does it make sense? But what also stood out from our discussion is that aside from learning and keeping up with the trends in industry, can you actually learn what the industry or what the market needs, right? So we're not just trying to equip students with what is trending at this time, whether it's cybersecurity, whether it's big data, but can we also be able to help them predict where the trends are heading, and then people can be able to be prepared in advance. And us as professionals or lecturers or professors, can you help your students be able to prepare in advance by predicting those trends? Then diving into the interdisciplinary, we had to try to cover out and distinguish between multidisciplinary and transdisciplinary. Many folks use these terms interchangeably, but in reality, it's actually different. So what is interdisciplinary here is when disciplines come together and integrate their ideas and come up to address a problem. But the multidisciplinary is when each discipline is given this problem and they address it from their unique perspective. The transdisciplinary side of that is getting those integrated ideas, those interdisciplinary ideas, and then try to apply them to a broader societal issue. How does it translate into that space? So that helped us then try to cover out and understand what the interdisciplinary strategy was. Now we looked in different aspects. So starting out with definitely our folks who are really experienced is that if you reflect back on your interdisciplinary experiences, how did that come into play? How were you able to utilize them? And folks were able to share that they've worked on interdisciplinary teams, played critical roles, standing in as the middleman to communicate with folks maybe who didn't understand or bring together or try to synchronize what other team members were not able to communicate or relay. And also what was really pointed out is that you need to learn to listen, because we come from diverse disciplines, but do we even take time to listen to each other so then we can work together? If we're trying to enforce what we know and not listen to the others, then we might not be able to come up with a solution. And then this comes into the terminologies that are being used. The other aspect we touched on is the challenges and benefits of interdisciplinary teams in workforce development. As you can see here, there's so many challenges. We might find that it's exciting, but on the general scale, there's a lot of work that is still needed. First of all, how can we be able to help individuals, sort of carve out or pave way for the career pathways that are needed for interdisciplinary folks? It seems obvious that, hey, I could be a data scientist, I'm working in health informatics. And it seems obvious that, maybe it's common for me to get a job or position somewhere in a hospital or, a lab somewhere, but it's may not be as obvious for all cases. And does that actually make me interdisciplinary, or am I a multidisciplinary person being applied in a certain space? So we also discussed that there's lack of resources that are available out there. Are there specific interdisciplinary publication venues that are available, right? So again, trying to find that integrated part of it all. Finding the right job, the right fit, again, comes back to, am I an individual as a discipline, or am I able to get into an interdisciplinary context as apart from being pushed to one end or another, and so on and so forth, language issues and others. Now, the other thing that came up with the disciplinary issue is that people are competing. You have disciplines that are competing. In larger institutions, for example, you might find that folks might be willing to hire or contract out some of their tasks. But in smaller institutions, you might find that they're more willing to actually collaborate and push forward that interdisciplinary effort. And then from the benefit side, there's opportunities to learn, and that's what folks really appreciated, right? So you learn amongst yourselves, you learn together, you learn new terminologies, you learn that your skills, your knowledge can be, pushed out and broadened, or increasing understanding in other areas. Then we also discussed if there are opportunities, folks had opportunities for being mentored or supported. And students, for example, shared, that there are various educational programs that are available to promote this interdisciplinary effort, whether you encourage your students to go and attend a course in another discipline. Obviously, the question there was if you don't have time, or if this comes up later and there's no time to take additional courses while you're wrapping up your program. So how would that, be of benefit? But also setting up institutional-wide boot camps was something, seed funding that also motivates individuals to, be forced or encouraged to work together, and also having working groups, that have folks trying to tackle specific topics, again, bringing up or highlighting the interdisciplinary energy. Now, before Mark walked in and asked us to head to the facility, we were starting out to discuss some of the strategies to bridge these gaps. And some of the things definitely that came up is how to involve people who are highly motivated. And you'll find that in institutions, for example, when you have new faculty joining in, they're usually so excited. You have new faculty members, postdocs. They bring in this wealth of, energy, they're fresh researchers. So how can you get those folks and put them front and center, right? Have the administration put them front and center to promote, interdisciplinary work in the research space, which then is geared towards workforce development for their students. And of course, we want to also highlight that it's important as different disciplines, you have your own terminology that you use, but these terms can mean different things to different disciplines. So sitting down and fast ironing that out is very critical. Again, coming back to the aspect of listening. But moving forward, and something that was I personally thought about is that even if we are all working as different disciplines together, it's important that maybe some of the disciplines or interdisciplinary teams may have more issues, others may have more successes. So we want to take this out, roll this out to the different HDRs, and then, sort of start information gathering and see what are the challenges that they have had, what are the successes that they have had, and then bring all that together into, to identify any similarities or variances, and from that extract, themes that can be then, focus points for further discussion, maybe at the next HDR ecosystem, and try to help out. So I hope computing folks are more, we did not hear very good good points about computing folks. They do not know how to communicate, but the science communication talk that was given last time was actually something that would pave way overall to encourage people to learn how to communicate within interdisciplinary teams. Thank you so much for listening.
Thank you.
Any questions? Comments?
I will say physicists sometimes have issues with communicating too. Are there other, great talk. And I'm so glad you also talked about the forward-looking elements. Fantastic. Yeah. Questions? Comments? Thoughts?
Thank you.
I have one.
Okay.
What do you think of the So about the role of so one point I wanted to say, I really like what you said about the forward-looking, as the sense of being realizing that the field we're in moves incredibly fast. I mean, I'm in a field of particle physics and physics in general and I'm an educator, and often the physics, we don't have to worry about the ground shifting. I mean, much of what we teach our students are, are decades, if not often centuries old, established science about the world. And particle physics, to my chagrin, sometimes doesn't move extremely fast in terms of developments, but AI and data and learning from data AI is so rapidly moving. And I have, this is a challenge I have in my own classes, is that I look back, something I taught 2 years ago is like, I look back, oh, I'm talking about that. Yeah, that's kind of, nobody does that anymore, like capsule learning or like, whatever. So I really like what you said is teach, if I remember, paraphrase, teach to the things that will be relevant. I mean, like, I forget, you said it much better.
Reinforcing them to help them to learn or predict the trends that are coming up in the market, as opposed to just teaching them what is relevant at the time.
Exactly. So really, so this requires some care, like you've shown it, like thinking about what will be, since we're trying to do a workforce development, what will be relevant in the future and not because it moves so fast. So I think that's an excellent point. The question I had is, I didn't see it here, but do you think that, what do you think the role of mentoring is in workforce development? I can see both. So in A3D3, and we actually pair our postdoctoral fellows with a mentor, and actually each of our members can be paired with a mentor that kind of is just someone to kind of check in with them, see what's happening. That can be both empowering, but also I've always worried a little bit that, it can be intimidating as well, because, and it can lead to, if it's, you really have to be careful with the mentors, because the mentors can lead in a direction and maybe be more constraining and not allow the growth of the person. So mentoring can be a double-edged sword, but I just want to, is there a role of mentoring in our community in the workforce development? What do you think about the?
No, I think that's a very important question. And I think, yes, we should be able to identify mentors at different levels, but also because maybe students might be intimidated by, individuals who may be advanced, but also getting peer mentors can be a starting point, and then gradually, fitting that into, more advanced mentorship, and then crossing into maybe industry. So it shouldn't just stick within the academic circles, but out into make it a parallel thing into the industry, and then mentors into the community to see a broader scale of how the impact of what they're learning could, do to the community. Yeah.
Yes, excellent. And you do have mentoring here, I
Yeah.
see. Yeah, and I like the idea of mentoring with an industry partner, because that would also help as a component. That would also help this question of making sure you're aligned with things that are the trends. And not like the ancient history, which in AI is like yesterday, right?
I know.
So I like the idea of industry connection, because it helps, because the industry is, they're driven by factors that we're not in academia. And therefore their livelihood depends on being able to view the trends, and that would help. Thank you.
Yeah. Thank you so much.
Okay, yeah, thank you so much. Let's look at this, Josephine, and all the speakers for this. And I think now we should talk about I don't know where, that's okay. I think we should talk about the white paper, and then I think Phil, you'll give your summary and, right? Yeah. Okay. And then I have a summary I'm still finishing, which is going to be truncated. Yeah, go ahead. We at the coffee break? Yes. Stop me if we are. We probably should. Are we at the coffee break right now? Oh, coffee break. Yes. Okay. We'll come back. I mean, it's right here. So we'll kind of, if you want, we can make it a little bit of a short one, because I've already had the coffee and the food. But yeah, let's take a break, because we need more of a break than we probably need coffee. But 10 minutes. Let's do 10 minutes, and then kind of bring your stuff over. We'll start again. In fact, I think the white paper. I think you just split. I think you just show. I mean, there's some way of.
Maybe,
just
I think
make-
you have to stop sharing if you want to.
Oh, you do?
Yeah, right.
Okay, I can stop sharing and reshare.
Then
It's no
come
problem.
back.
It's no-
Okay.
Excuse me, who were the others that were going to go on the tour at 1 o'clock? There you go. I know there were 3 people or 4 people. There's 7. Oh, there you go. So she just wanted to make sure she wasn't walking, alone. Can you all coordinate? Do you see the people? You see who's there? Yeah, Elizabeth. And so if you could meet in the atrium and walk together, that would be best. And there should be other people. I will send an email I'll send an email out as soon as I get a second.
Yeah, that. Yeah, you can come on. Yeah, right. Yeah.
I think maybe we can start again. I was just going to say a couple words on the white paper planning and then let Phil do his summary. Okay, so we, as I've discussed before, we want to have a white paper for sure. We want to have, it would achieve two things. It would be the conference summary, and it would also be the a position paper from the HDR community. So I think it's, which is visionary over the rest, not only over the rest of the HDR program, that would be part of the conference summary, because we just discussed that each of the topics would have, each of the breakout sessions which are related to topics would have some actionable items that would be, what should we do over the next year or two, so that before the next HDR and beyond. But I really think that we would benefit as a community also to describe how we've built a community through this program, and how the community is strong and getting stronger and well aligned with the theme of learning of AI and data, and really highlight. I mean, I think this is what either Amy or Katie said, is just, yeah, I think it was Amy actually pointed out just how this is the community within at least the NSF, but I think as a community of researchers that really is the best position to be very data centric and, AI on data centric, right? So, I mean, a lot of the AI institutes are very much a little more theoretic or a little more foundational and cross-cutting with domains, but we're the ones that are really focused on data and learning on data. So I think we want to describe a vision for that, and how this is something that's only strengthening in the broader community about learning from data. So that's where I'd actually like to hear everybody's feedback on the white paper, but this is sort of where my head was at, about both a visionary part, a summary part, and near term and longer term the vision is more the longer term, but practically what we're going to do through the rest of this program. That was, does anybody have any general comments on what they would like to see out of the white paper? We can pass microphones around. Yeah, go ahead. There's a microphone right on the table. So there's some logistical, practical stuff we can talk about, but yeah, just sort of on the framing of what we want to do with the white paper. Does that?
Yeah, so how we're gonna work so many people, so many topics?
So now you're talking about the logistical part.
Okay.
Yeah, let's talk. Anything more about sort of on just the overall framing of the white paper, the goals of the white paper. Is that kind of what we want to do? Let's get into the logistical part, and then you could ask. Okay, paper, where is it going to go? Well, we have an archive. We want to put on the archive, but I think we want to really go beyond that. I think we want to, many journals these days, and I've talked with the editors of the Machine Learning and Science Technology, they have tracks that allow you to publish through their peer-reviewed process and publish conference summaries. And so MLST is one that I know has a conference summary publication. We should explore, we don't have to decide this now, but I do think we want to have this. We want to elevate this. Last year was great. We had like sort of a one-page summary that's on the web page. But I do think we're at the midstream now, and I think we have enough content to really make something that is in a journal, published in a journal. So I'd like to explore that. We can decide exactly where that is. So that's the one thing. How do we get there, though? I think what we have Phil has created an overleaf document. And I think probably this community, we know LaTeX, right? Because so we're not going to do this in Microsoft Word, God forbid. LaTeX just does the references. It's just, we're not going to do it in Word. I will leave the ecosystem if we're going to do this in Word. So we're going to do this in LaTeX in the overleaf. And it just means many of you already have overleaf accounts. If you don't, you should get one. The way I see the authorship that we've done is, I mean, everybody in the ecosystem who would want to, I mean, everybody, certainly everybody here is an author on the paper, but we do have to manage this in a way that we have chapter editors. And I think the chapter editors should probably be the people who led the breakouts for those particular things. There'll be cross-cutting elements. And so one of the things we should decide, I don't know if we could do this today, but we should flesh out the outline or the sort of structure of the white paper, and then I have assigned people so that, because unless we have people assigned to feel responsible, and it doesn't mean they write everything, it means they're responsible for that section to, get at whatever information, maybe have other people write parts, but we do need people responsible, and these would be kind of like chapter editors or section editors. Yeah, probably. Oh, there's probably somebody. Oh, sorry. Thank you. Yeah, let me stop sharing. Get to see that. Okay. Yeah, again, I'm really, okay, so what other I think that's really it. So then there's a question of timeline. I feel like we really should push on this because I can tell you through my own personal experience with organizing other conferences over years, it's almost like conference proceeding. Does anyone here actually really enjoy writing conference proceedings? If you do, you can raise your hand and don't be embarrassed. But I can't stand it because all this work goes up to a conference. You get to talk at the conference, and the next thing you want to do is get back to all the work that you've had to push off because of all the work to the conference. But then you have this proceedings to write, and it's like, oh, now I'm trying to remember. So the longer we wait on this, the more painful it becomes. So I do think we want to push on this is why I hope, for those that can be here, I know this is a travel day for many of you, but we have all these wonderful rooms. I really would like you to either continue the discussions you had for whoever's here, but really try to flesh out your part of the white paper. The fresher it is in your mind now, the more we're all going to go back to our daily lives, and it's going to be something that'll become an increasingly large burden to write this. So let's try to get, while it's fresh in everybody's mind, the raw materials. Doesn't have to be the polished prose, but let's really try to flesh out the sections, or at least the raw material for the sections. Okay, that's all I had to say. So timeline, I don't know. I mean, anyone want to throw something out? I mean, maybe we should have a good draft in a month. I don't know. I would think more than a month, we're going to run into struggles. We're not going to finish the white paper today. So somewhere between today and a month, I think we should have a good draft that we can then, I mean, I'm happy to overall edit it. But I think we should have something that's pretty okay in a month relatively, or is that way too ambitious? What do people think? Sounds good. Okay. Now, do you have anything on the practical part? Is that gonna? Okay. So that's, yeah. Yeah, go ahead. Microphone is right there.
Yeah. Regard to possible outlets for this paper, I don't know whether folks have thought about the Harvard Data Science Review, which is an open access journal, has, I think, done a pretty good job of accommodating broad scope, multidisciplinary data science related topics. I served as a reviewer for that journal for a few papers and know the editorial people. So if that might be of a target, be happy to facilitate.
That sounds great. The one I was thinking is actually not maybe the best fit because I know they have a conference summary track, but I think what we want to do is beyond a conference summary, as I discussed, right? I hope we have from the HDR ecosystem and the community, I hope we can have more of a, kind of a visionary paper, a position paper, if you will. Position paper sounds too dry. We want to have a summary of what we did, but really we want it to be visionary. So it's beyond a summary. So maybe just a conference summary track in MLST is not great. And maybe the Harvard Data Science Review is more appropriate. I'd have to look at examples. Yeah. Oh, you were an editor were you on the editorial team for that?
No, I'm not. I helped with the reviews for some papers there, but the journal is not about publishing conference papers. It's about publishing usually journal type of work. Like overview, like review, and sometimes even research.
Whereas I think we definitely do not want to we don't want to review data science. Like we don't want to put a review article out. That's not, I think what we want is some mixture of a summary plus a vision for the future. So if it was really about review articles that we don't want to review beyond the ecosystem, for example. Like we don't want to be in a position to review data science generally.
Right. Yeah. So I think the title of the journal is misleading. I don't think it's a review journal.
Okay.
But yeah, it's a potential target. Just want to perhaps bring.
Yeah, I think so this will go, I think also we should just, one thing we really should discuss is not the second, but in the closeout, I want to talk a little bit about how do we, so like, for example, you have a great idea of this journal. We have other possibilities. Maybe other people have, how do we communicate after this? We might want to think a little bit about that because like, yeah, we should think about how we communicate overall as the ecosystem and especially for this white paper, because I would love to hear suggestions. That sounds like a great one. I'd have to look at some good examples. I'll remember it and try to look at, or maybe you could distribute some examples, but do you think it's a good fit from what we described? May or may not be from what, if it's really a summary plus vision.
Yeah, I think there seems to be some fitness there, but just a random thought as you were talking about possible outlets.
Yeah, I think we're not wedded on the outlet. I know MLST would do this. I think we could do even something like Nature Communications. We've done something like that. Okay, but open to suggestions. Yeah, I think it's kind of thing where we have to worry about like format and size space considerations. That does factor into where we want to go with it, but I think we're not even close to there yet. I think the journal could be decided in a bit later. We need to just get the thing going. Other thoughts on the white paper that weren't covered? So I think one of the actions would be everybody in this room should just get an Overleaf account so that when I share it, you just can log in and have access to the Overleaf. But I think we'll do it in Overleaf. Okay. So that's the plan for the white paper, but I think I didn't hear any dissent on the month, but let's think about how we can communicate about this and then also try to keep moving on the draft. So that's why I think please use the time you have today after this, use the breakout sessions and flesh out your piece, flesh out the parts. And then the cross-cutting stuff can be written by sort of other people and more of a general editors and stuff like that. But I think as far as what we saw today, flesh out your bits as much as you can while you're still here. Okay, that's all I had then. I guess that would be the plan. Any other comments on that? Otherwise, Phil, do you want to go ahead and talk a little about the summary, and then I'm going to try to finish my summary. And you don't have to do the whole thing.
I think this is right there. Yeah. Okay.
All right. I don't know where you're.
It's fine. I got it. All right. So I was asked to give a summary talk. It's always hard to give these summary talks. Especially when there's multiple sessions and you can't attend them all. So I will focus kind of on summarizing the general session. And more generally, right, here. How do I do full screen here? Okay. All right, so more generally, right, the kind of point of this conference is to put some framing for the data revolution, right? So what is the data revolution? So, if you go to kind of Google Analytics, and you try to see what the data revolution is, you can see that it's some term that's become popular. It started about 15 years ago, or 2011. And we see it's starting to grow. I wouldn't say it's an exponential growth. If we compare it to the term scientific AI, which you would think might even grow faster, I would say the growth rates, especially recently, are kind of on par with each other. So the point being is that AI and data, are starting to grow quite rapidly. If you want to normalize this to like a control, I just put NSF data here, and you can see that's kind of flat. And the point being here is that you can't have AI without data. The data revolution is kind of critical. And we're starting to see, right, that, these things are coupled and kind of intertwined. You can also do a little bit more research, right, in terms of the data revolution and ask yourself, where do people care about this? And interestingly, you see that the kind of coasts like scientific AI, but the center of the US likes the data revolution, and Alaska, North Dakota, or South Dakota like NSF. But point being is that, you know, there is kind of cross-cutting interest, right, for this data revolution. And these things go hand in hand. And these things are intertwined. And it's important to not get overhyped by AI, because you really can't have AI without data. So how has the harnessing the data revolution evolved, right? We started in DC. And there, I think, you know, this is a PI meeting. We're trying to just kind of get the institutes, like get their grounding. We're trying to understand how we're going to run our institutes. And it was more about meeting everybody and understanding what people's motivations were. Next year in Denver, we worked on building kind of cross HDR collaboration. So there, the meeting was very much kind of open-ended, unconference organized. And the idea here was to kind of connect institutes and build initiatives, right? And out of this, a bunch of kind of nice initiatives came, like the machine learning challenges and the educational database. This year, right? So first year, right, we named the conference from harnessing to harvesting the data revolution. So HDR squared. And the hope was that, you know, at some point we actually would get to the point of harvesting the data revolution. And I'd like to think that things are now starting to come together. And, you know, we've seen this with the institutes, that the institutes are starting to have kind of more and more exciting results. And, you know, they've developed as matured as institutes. And there's now a lot of motivation for us as institutes to kind of connect with each other. The other thing I'll say is that the kind of posters and advertisements have gotten a lot better, thanks to using generative AI. And you know, I think that's kind of the subtle undertone of the whole conference, and you know, the way things are going is that we're starting to have tools, right, from the data revolution that we are harvesting, and we're helping them to kind of make our conferences and, you know, connect everything together. And important thing is that, you know, people are starting to recognize this. You know, I just to highlight the first talk, there was there are new majors that are kind of emerging, where we're not just connecting computer science, right, and majors, we're also connecting data science and majors. And I think this is, you know, something we're seeing at many institutes. I can tell you though, this is not universal, right? We tried to do this at MIT. And the computer science department said, refused and said, physics is not important enough to be a major with computer science, right? That's literally what they said. And the point being is that I think we have enough people here, right, amongst the 5 institutes to make it important that, you know, this kind of path towards, you know, modifying, you know, your universities, extending to data science is kind of critical. And, you know, making sure that the message that data science, you can't have, you know, science without data, and you can't have AI without data, is kind of critical to, you know, what the message we want to do here in the HDR and going forward. So, you know, the point being is that if we're dealing with the, you know, information age, right, we can use generative models to, you know, do our homework, but ultimately in the end, we're cheating. We're just kind of pulling, you know, vapid information out of the air, giving answers, and you know, we're not learning anything, because the only way to kind of make your answers better, you know, improve your homework, is to inject more data and more ideas. And that's the kind of thing that I think we really have to focus on. So if you look at an LLM, I think it's about, the typical LLMs are about 10 terabits of data, right? I know everybody here uses way more than 10 terabits, right? This is kind of peanuts for everybody here in the community. And you know, if you go online, people say, oh, we saturated our data, right? We're kind of at the limit, right? And all our models are just going to saturate, and, you know, AI is done, right? And there's a lot of these kind of, you know, projections that say that. But I think this is where our kind of community plays an important role, because, you know, we know that there's way more data out there. And we know that there's ways to kind of integrate this into the community and, you know, harness it or harvest it, so that we can actually make, you know, models that go well beyond. And, you know, this is kind of where we started at the conference. So we started with Amy saying, look, there's lots of initiatives now. it's time to start thinking about how we as a group can kind of push forward and bring a coherent message, right? And I think this is the point of the white paper. And now that we have 5 institutes that are kind of up and running, we can start to see where we fit in the landscape of, the rapidly developing AI. So with A3D3, right, we saw that we're using kind of common hardware, software applications and AI integration to kind of connect a bunch of disparate domains and allow us to kind of centrally think about problems, right? These are kind of hard science domains. What we saw with ID4 is, again, a kind of transdisciplinary approach of, taking data and taking simulation and injecting kind of knowledge guiding approaches, inductive bias, into our ML, so that we can generate a full design cycle that's, building new materials and connecting kind of, engineers with the quantum mechanics of the materials that we simulate. With image-omics, we saw an end-to-end alignment that went from, basic, collecting data, in the field to, featurizing it, using all kind of geospatial and genetic and image information to come up with, AI that starts to learn how to actually classify and structure, many different species. With iGuide, right, we start to see that, we can connect all of the US, right, both the AI excited part and the data excited part, into one giant center, or one giant, huge swath of information, where we start to actually connect kind of all of the information we have about the US or about the structure of the US into some coherent message about how things are evolving and how we manage our infrastructure, manage our country. In terms of IHARP, right, we're starting to address a very critical, the very critical issue of global warming through very accurate modeling and understanding of what's going on in the poles. And we see now, right, after 3 years that not only have we been able to curate data, we've been able to kind of harness ML, and we've been able to kind of develop inference strategies or analysis strategies that are starting to lead to important scientific results, right? And I think this is, we should all, this is the big success of the Institute so far. And I think that out of this, we're starting to come up with important questions, right? If we look at Vipin's talk, he gave us a bunch of challenges and things that have kind of emerged from all of our study using all these different types of data, right? And I won't go into these details, but these are basically all of the points that we had breakout sessions on. And these are points that I think we as scientists find very important, but are not necessarily well known amongst the whole data and AI community. After that, we heard an NSF panel where they gave us a whole list of exciting opportunities for us to apply to. But there was a kind of resounding message that came out of this is that we should understand what us as the HDRs produce. And more generally, it would be nice to show that the whole of all of our institutes is greater than the sum of the parts. I think this goes without saying, but the point being is that transdisciplinary convergence, building these disparate ideas, taking AI, taking data, all of this is starting to converge and it should be something that we should really highlight. So it's something we, it's basically just pointing to the direction of white papers, summary papers, and things to highlight all of the work of our institutes. So where do we go from here? Well, we saw in Katie's talk a discussion about the kind of NAIR pilot, right? So the NSF has been very eager, along with many other government foundations, to democratize AI, so democratize computing. And so they've now built a whole infrastructure that allows us to kind of distribute, put computing across the US and make it accessible to everybody. And I think we're starting to ask the question of how can we harness, right, this computing to deal with the core scientific problems we care about and kind of engage the greater community. And it's nice that we have lots of computing, but computing is kind of useless if you don't have interesting problems and interesting data. And so Katie had one short slide on data. And, you know, she said that it's a harder challenge, and it's something that I think here we can play a very important role. And, you know, there's certainly guidelines for having data here and making it open source. But the part that I don't see in any of these points is how do we harvest this data? How do we kind of use the data effectively in the context of all these computing resources and, you know, trying to kind of engage the whole community, the US community towards research. And we did see an example of this, right? An end-to-end example where we saw at Argonne, they had this giant computing cluster and they want to use it to its maximum extent. And so they've built a whole end-to-end kind of design study to build giant, you know, foundation models to solve many different problems, right? This is a kind of closed loop, right? They do this at one site. They have a lot of people, they have a lot of data, and they're trying to kind of do the whole design cycle themselves. This kind of model is maybe an example for how to kind of, you know, incorporate, you know, include all the HDR. Well, this is like a kind of the opposite in some ways of the HDR, because it's a, you know, single site, you know, with a lot of resources just solving us, you know, collectively solving problems they think are important. Here as a community, we need to think about how we could extend this to the whole US, you know, with the ideas of exploiting NAIR and kind of integrating our own research, right? But I do see this as a prototype for maybe, you know, foundational models or foundational scientific models for how we can kind of exploit big computing centers in the context of the HDR. All right, so then we saw some talk from Deming about connecting with industry. And so he presented some ideas of how we can integrate, you know, new processors like AMD processors and other FPGAs into a kind of harvested or integrated system. And then we heard from a panel on AI and data computing, where there was a lot of discussion about, again, kind of along the lines of NAIR, how do we democratize AI and how do we engage? And there are a lot of suggestions about how we go beyond the narrow scope of engaging, right? You know, we have a computing center, right? It's very easy to invite everybody in Urbana-Champaign, come see the computing center, give a bunch of talks, engage them. But how do we engage people, you know, in Bismarck, North Dakota, where there's no computing center, right? And so coming up with challenges and ways to reach out to the kind of, you know, whole US is something that was brought up, and, you know, we're starting to think about ways to do this. So ML challenges are good initiatives to anybody who has a, you know, network connection. And harnessing these ideas can help to democratize the usage of computing and the usage of AI beyond just the kind of, you know, data centers and, you know, the areas where we have expertise kind of located, like nearby the data centers. Then we heard about the ML challenge, right? So this is launched. The kind of highlight I'd say is that we have a completely fair set of workflows. Everything's on GitHub, reproducible, standardized containers. With A3D3, we're looking at unknown signals in our universe, right? So core collapse, supernova, all sorts of strange astrophysical phenomena that we can't model, we don't understand, and we're trying to look at this with gravitational waves. With IHARP, we're looking at the Earth, and we're looking at anomalous patterns that generate sea level rise, right? That can, in this case, we look at the east coast of the US, but the hope is that this generalizes, right, to the globe, right? And we don't need to necessarily put monitors everywhere in the world, but we can actually use satellite information to monitor everything in real time and understand, you know, when the sea level is going to have substantial effects on Earth. With imagiomics, we saw how we can identify new species, right? And it's not just identifying new species, it's identifying all the subtle features that we can't model well, right? And now, you know, we have a plan for going beyond this, right? In terms of cross HDR resources for education outreach, so this is another cross HDR initiative like the ML challenges. We saw a 3-phase plan. The first, which is already created for an educational database, right? And now there's discussion about expanding the scope, sharing resources, allowing us to kind of share all the educational input so that us as a community can share our ability to do data science education throughout the US. And then this led into a panel in the workforce where we talked again about how we can make computing accessible to the community, but also how do we engage the community in learning the tools? And so there are a lot of ways to do this. Certainly there's the rise of LLMs and machine learning in general helps to make some things easier, but it also forces us to teach things differently. And it opens new and difficult questions that I think are important to address now. All right, so then you can ask the question of where do we go in the future? So we saw in Suresh's exciting talk that there's been a lot of hype about, LLMs. We saw this, kind of in Katie's talk where everybody's talking about bigger models. We saw this in the FAST talk at Argonne. Everybody wants foundation models. But Suresh made a good point that there's a huge amount of hype, but there's also a huge amount of frustration, right? So people are worried about AI, right? It's a little bit of a struggle to get, good information out of this. And so his view, which is a view I share, is that we're going to, we're probably going to the trough of disillusionment, right? So we're going into the trough where we get a little worried that AI is not going to solve all our problems. But this is the part where kind of real research, R&D makes an important point because it helps us to ask the important questions about, AI safety, AI ethics, data processing that we just haven't done in the past, right? That allow us to make AI actually a useful topic. And the point I'd like to highlight from Suresh's talk is in his conclusion, is that he had a bullet. The second bullet in his conclusion is that we can do this by being scientifically rigorous and using scientific discovery to expand the range of policy options. And here in the HDR, this is scientific discovery and scientific rigor is our focus, right? And this is something where I think we can play a kind of important role to kind of push the AI revolution out of the trough of disillusionment that's emerging, because we have clear scientific problems and scientific standards that we need to align our research to. I mean, that science is not going to lie, right? People and, the commercial industry is going to lie to us all the time. And so we have an ability here because we have clear data, well-defined objectives that allow us to kind of push AI and test AI in systems that are kind of independent of humanity and allow us to really exploit science to develop AI and solve some of the most critical problems that we care about. So where should we go? Well, in the interest of trying to use AI for this, I asked ChatGPT, how can I make sure harnessing the data revolution continues beyond 5 years? And it gave me a very generic, boring list of what to do, right? Engage the community, demonstrate the impact. And so I got a little annoyed. So I asked, can you elaborate on what the secret sauce for success would be? And it gave me an even longer list of basically useless information, sustained funding, nurturing talent, innovation culture, right? A bunch of buzzwords. So I asked it again. I said, this answer is just stating the obvious. I want something useful. And then it gave me a list of like 30 different options. And out of that, I got one thing that I thought was kind of nice, make it cool and ubiquitous, right? And that's something I think that we're at the stage that we need to start thinking about. How can we make HDR cool and ubiquitous? And that's I think the goal of harvesting the data revolution. Is that, we've seen that we have lots of exciting results, but I think it's time to start being a little more public facing and showing that what we're doing is cool and ubiquitous. So we need to go from, a field of harvesting to actually making kind of delicious meals. This is a completely corn meal. But we could, to really make it cool, we might want to think about doing some molecular gastronomy and making, something that just blows everybody's minds. So in an attempt to use AI again, I tried to combine all of the HDR institutes in a single image, and it was kind of disappointing. So I added ubiquitous and cool features of all the different institutes, and I picked their kind of topics, and I got this strange image, and I played around again. I got some other, probably better image, but I don't think it highlights any of the institutes. And then finally, I finally went to DALL-E because I was trying to use free generators before. I got this, which honestly is even worse than the others. And then I just, did a Google search and I got this. And to be honest, I thought this was the most demonstrative. It has a nice message. It shows the diversity of the research that we do, and it shows that we're all working together. And so my point with this is that I don't think AI is necessarily ready to solve all our problems, as many people want to say, but people working together, exploiting AI, searching carefully on the internet per Apple can come and, put together a coherent message for the HDR. So in the next year, right, we've seen the institutes connecting over a broad range of domains. These connections within the institutes are producing significant results. I think we need to start thinking about how us as a kind of each institute can connect, make a common collaboration that can highlight the criticality of our work. And so the combination of data and science can hope to serve us, push us forward. So thank you. Questions?
Cool. Compare data revolution, French Revolution.
Yeah. I mean, again, right, this is me. I was trying to find some like American revolutionaries and like a nice image. But I mean, this is in terms of a revolutionary poster, this is the one that I always, historically come to mind. And, it's a very symbolic photo or painting, right? And it's the kind of thing that I think, we're in an opportunity to lead, right? So.
Yeah, it is true. Now that we've harvested the data revolution, we're looking for a kitschy follow-on to that for sure. And yeah, these are great attempts. We should see if there's any other questions. Yeah, great summary. I really loved it. Yeah, and also the parts about the vision for where we should go. Yeah, so I think we all should be super excited about what we just did and where we're going to go with all this, because I assure you, this is not going to be over, even after the 2 years. It's going to be maybe the HDR as a project, my program might change, but I think there's lots of great stuff ahead of us. Okay, thank you, Phil. Let me just yes, thanks, Phil. Oh, we can still clap, but
Thank you for the great summary. I have one question. You mentioned that for the next few years, you would like the different HDR institutions to collaborate. Can you elaborate on that? Like, what are your thoughts on what type of collaborations do you want to see? Like, is the exchange of ideas, problems, solving common problems, or what are your thoughts?
Yeah, so I mean, let's if we go back a year, right? We had an unconference event, and the idea at the time was basically to cast a wide net and find things that linked all the institutes together. Out of this emerged two very concrete results, right? So the ML challenges and the educational database, right? And so these are things that I think are already good examples of how we can connect the two or connect everybody. The point of this white paper is to find a list that we can all sign on to, right? I mean, all of us are going to be authors on this paper, right? This is something, we want to publish, something we want to highlight. And so I think the important thing that we want to think about in the next month is how we can connect. This morning we heard, from all the breakout sessions, a lot of very concrete kind of topics that I think we're all interested in. And I think we need to spend the next month, distilling these, right, and putting this in a white paper. And then, exploiting the fact that we do know how to collaborate, right? We have concrete examples, and expanding the scope of what we would like to do across the institutes.
One thing came out yesterday. I think Gigi and Shaman was there. So we're thinking the websites right now, NSF HDR, can be greatly improved to outfacing. It's not just your own institution, but overall ecosystem. How people going to the system can easily get things like demonstrated use cases, examples, educational resources at a central place. Maybe they can also send out newspapers, newsletters like that. I think those is one thing we could do before next year, just to make it go beyond what's current funded PIs and students, but outfitting for the more general public.
Yeah, I mean, this has been brought up a few times. I agree, our website is not great, right? nsfhdr.org. And I think there's an effort already to start connecting things.
Yeah, that will dramatically improve.
I can actually speak on that. We had a conversation yesterday with all the institutes, and we are going to be creating a website to host all of our publications, all of our educational materials that are already being placed in the repository. Ryan, who you guys have seen around taking pictures and helped with the video, he's agreed to kind of take on doing some marketing and communications efforts for the ecosystem. So he will be probably contacting people to write research stories about efforts going on throughout the ecosystem. This website is going to get an entire refresh, rebranding. So we are decidedly going to make more efforts to create more of an ecosystem and also show the impact that we're making through that.
So we should talk because we created I created a GitHub organization for the HDR ecosystem that the website is driven off of. But we could host any website there and it would be so I really like the GitHub part because we could all contribute, like we could put our educational repository there, the machine learning stuff, and it could be called nsfhdr.org. And it doesn't change anything you said, except for I don't think we need to create, like if we want a new website, we can do it in the GitHub organization. So we should follow up, but we have the Google pages that were created by Tanya first, and it just hasn't really evolved, right? And so what's that? Yeah, so I have created an organization that we all can be part of. It has nothing to do with me. It's just that there's an organization that's under GitHub. Okay, hold on. And we can I highly recommend we use that organization. If there's new websites, we have a splash page, and GitHub actually has a mechanism that an organization, you just create a .github and it becomes the splash page. And repositories can be additional pages. So all I ask is that we work under the GitHub organization framework. That's all. So I can coordinate with Ryan or whatever, rather than create yet another separate thing. That's all I would say. Because GitHub is the way to go. GitHub is how we collaborate software-wise. I think it's really the best way to, yeah, go ahead.
Right. I think what I hear right now is that many of us are so excited how to bring the HDR ecosystem in a consistent out-facing message. So I already anticipate that there will be a follow-up meeting dedicated about the discussions, the technology and the infrastructure we want to do. And each of these, sorry. Yeah, each of the institute already have a supplement grant. And we had a discussion yesterday, exchange some idea how we can maximize the value of that supplement, allocate some of this from each institute to contribute to this effort. And we should continue to do this. And I would like to echo one of the comments that Xiaowen mentioned earlier about the scientific paper or conference proceeding. The white paper, I would consider that as a inspiration. I would like to see from the white paper, we actually spin off many joint paper across the institute. You could start thinking about the data challenge in the other institute, or I have a solution, or I have an application from my research, I can actually apply to that. That's the starting point. We can perform the transdisciplinary research because the different disciplines together and come out with new solutions. And this might give us some surprise. So I think this is actually the real starting point. It's the reason why Mark tried to push very hard. Let's try to wrap up this white paper as quick as possible because we can use the rest of the time focus on the science.
Yeah, so we're all good. We all have the same intent. We should just figure out the mechanics of it. That it's all good. Yeah, okay.